The Chinese have announced that they're going to go to the moon. In fact, they will probably beat the United States.
For ages, the moon has captivated people, shining brightly in the night and then slowly fading into darkness. Recently, scientific attention has shifted back to the moon, revealing unexpected resources and water. But what does this practically mean? Are regular lunar flights on the horizon? And what awaits us? American astrophysicist Dr. Michio Kaku shares insights into the latest developments. Join us on this intriguing journey to the moon where fresh perspectives await you. Humans are venturing to the moon again, and it's surprising that no one has returned since 1972. The extraordinary Apollo 11 mission in 1969 marked the first human steps on the lunar surface, watched by billions. Apollo 17 in 1972 was the final manned mission. It's been so long that many of us weren't even born when these historic events unfolded. Renowned scientist Michio Kaku recently mentioned that China seems to be the only country taking lunar exploration seriously. China sent a robotic spacecraft to collect rock samples from the moon, a significant shift in lunar exploration. Kaku congratulated China, noting it was the third country to achieve this after the United States and the Soviet Union. He also considers this development might trigger a new space race. During the Apollo missions, the USA and the Soviet Union had fierce competition. With more nations entering space, Kaku warns that tensions could arise, especially when it's not just about exploring celestial bodies like the moon. As more countries get involved, the commercial and economic aspects could come into play, potentially leading to conflicts. If China takes the lead on the moon, envy might arise, especially if their discoveries provide a significant advantage. This raises questions about moon ownership and the right to extract resources on a large scale. Kaku feels it's unfortunate that we have to think about the military side of space travel. He observes the current developments with a mix of concern and appreciation. Despite tough global competition, the United States has been leading in space exploration recently. Russia is gradually making a comeback after the Soviet Union's end and economic challenges. The US controls more than half of Earth's satellites, and Elon Musk is launching thousands of mini-satellites for a global communication network. While many nations have satellites for communication and weather observation, no one has decided who owns and has rights to the space around Earth. The growing amount of satellites and space debris is a concern, as latecomer nations might find it challenging to find space for their own satellites. To safeguard its interests in space, the USA has established the United Space Force, a military unit focused on space defense. Whether such a protection unit and military presence in space will be necessary in the future remains to be seen. For now, the return to the moon seems more like a peaceful competition between private space companies. Elon Musk, through his space company SpaceX, has long talked about plans to travel to the moon and even establish a hotel there, focusing on tourism and manned flights. Jeff Bezos, another entrepreneur interested in the moon, envisions it as a potential economic hub. The Amazon CEO proposes moving heavy industry from Earth to the moon to ease the burden on our planet. Bezos's vision might become a reality sooner than expected, considering recent discoveries that suggest humans could soon extract resources from the moon. Musk and Bezos have faced skepticism in the past, but no one seemed to view them as threats to space or potential triggers for international conflicts. Warning about potential military implications, especially if the USA or Russia falls behind in moon missions, Michio Kaku is now concerned about an unnecessary arms race in space. Reports indicate that the USA and Russia are already testing hypersonic drones capable of space deployment. Will finding water make a significant difference? China's Chang'e 5 lander touched down on the lunar surface in 2020, drilled deep, gathered a rock sample, and sent it back to Earth in a remarkable mission. This project by China has left many astonished, triggering curiosity and excitement among scientists globally about what this discovery could mean. Never before have humans had rock samples from the moon's depths in their hands. Though only a few rocks have returned, they have proven to be noteworthy. Chinese experts used advanced techniques like field emissions scanning electron microscopy, electron probe microanalysis, and Raman spectroscopy to examine the sample. The analysis revealed the presence of tiny glass beads in the lunar soil, containing a small amount of water. Chinese researchers concluded that these glass beads could permeate the entire lunar soil. If this holds true, there could be millions of liters of water trapped in glass on the moon. The notion that the moon is dry and uninteresting is now a thing of the past. Michio Kaku described the published study as a significant addition to our growing knowledge of lunar water. He stressed its importance for future lunar surface explorations, mentioning upcoming missions planned by the USA, such as the Artemis project, aiming to establish the first permanent lunar station. With the presence of water, this step becomes more feasible. The water in the glass beads can be made usable through heating, providing moon settlers with utility water, drinking water, water for lunar plant cultivation, and even fuel. Beyond practical benefits, this discovery deepens our understanding of water reservoirs on other celestial bodies. 20 years ago, scientists deemed it impossible for planets or moons without an atmosphere to have water, as it would evaporate or escape into space. However, on the moon, water appears to take a different form. While not entirely new, the discovery of water on the moon challenges previous beliefs. Orbiters and telescopes have already suggested the presence of substantial ice in craters in the polar region. The NASA Commercial Lunar Payload Services program aims to send a rover to explore for water near the South Pole by the end of 2023. There's a possibility that NASA might extend the mission to include bringing back soil samples to Earth. The discovery of water molecules on the moon, among other findings, can be credited to NASA's Airborne Observatory SOFIA during the SOFIA mission in the Clavius crater. In this joint project with the ESA, a telescope weighing over 17,000 kilograms with a diameter of 2.5 meters was regularly flown aboard a Boeing 747 into the Earth's stratosphere. Operating without interference from Earth's radiation and atmospheric dust, this airborne infrared observatory scanned various celestial bodies, including the moon, and uncovered evidence of water ice at the poles. Since its development began in 1996, SOFIA required unique technical ingenuity. The Boeing 747 SP jetliner had to be equipped with a specific kind of garage door that opened into the stratosphere, enabling the telescope to have an unobstructed view of space. SOFIA successfully detected water molecules in the Clavius crater's region on the southern hemisphere of the moon. The Clavius crater, the second largest prominent lunar feature visible from Earth, boasts a substantial size of 231 kilometers in width and a depth of 3.5 kilometers, serving as a silent witness to the moon's eventful past. Within the boundaries of this massive crater, there are likely additional significant water deposits, challenging our previous perception of the moon as dry and uninteresting. Now let's delve into the previously mentioned resource that could spark a moon race. The newly discovered mineral, Changesite, has the potential to revolutionize the energy industry on Earth. Is a unique crystal belonging to the broth subgroup, chemically associated with phosphate myrrolite. What sets this crystal apart is its high helium-3 content. This rare element possesses the capability for nuclear fusion, a sought-after energy type that physicists have been pursuing for decades with limited success. The primary hurdle has been the scarcity of suitable fuel to generate more energy from fusion reactions than is required to initiate the reaction. The increased fusion potential of helium-3 has been recognized for a while, but its scarcity on Earth ruled it out as an energy source. Now, helium-3 from the moon presents a chance to transform our energy needs with advanced nuclear fusion reactors. However, Michio Kaku, while optimistic, points out a significant challenge. Transporting helium-3 from the moon to Earth and establishing a mining operation there would require substantial investments. It remains unclear when or if using this resource would be economically feasible. Kaku contends that helium-3 nuclear fusion offers a safer and cleaner energy source, compared to conventional nuclear processes, with minimal radiation and no nuclear waste. He advocates for more research and views the discovery positively. The potential of helium-3 is vast. Just 25 tons could power the entire U.S. for a year. Valued at about $3 billion per ton, the moon could become a highly sought-after resource. The pursuit of helium-3 has sparked a global race, with private companies and countries with space agencies competing to harness this resource. The question arises, will these discoveries eventually harm the moon, or could they be the key to our planet's salvation? Share your perspective in the comments below and subscribe for more content.